So hello everybody, this is Dr. David Rosenblatt with you again on Food Safety Fridays webinar. I apologize for not being able to be with you in person. Something came up, but I promise to get your questions and answer any questions you may have. And I appreciate your feedback. And again, thank you for joining us wherever you are in the world for this webinar. Our subject is environmental pathogens, and I'm going to present an approach that we call CREEP, which means Comprehensive Risk Evaluation of Environmental Pathogens. And let's get started. When I hear the word CREEP, I think about the Radiohead song "Creep," and it is really appropriate for pathogens. But I'm a creep. I'm a weirdo. What the hell am I doing here? I don't belong here. I don't belong here, and so forth and so on. So if you're familiar with the Radiohead song, then the pathogens don't belong here. And if you're not familiar with the Radiohead song, please do become familiar with it. It's one of the coolest songs out there. So let's get started. What are the environmental pathogens mentioned? We include two environmental pathogens in this presentation: Listeria Monocytogenes and Salmonella species. There are other environmental pathogens, but these are the two major ones. They are the most important, and they have a lot in common. And these are the pathogens that are really special. And I'm going to quote the Creep song from Radiohead again. Why are they so effing special? If you don't know the song, when you hear it, you'll be smiling about why they're so special. So they are special for the following reasons. One, they're all over the place. We have Listeria and Salmonella wherever we have animals, and animals we have everywhere, because they are part of the intestinal flora of all animals almost. Then you can expect them to be anywhere, wherever animals are going to the bathroom, which is everywhere. Another reason why they're so special is because in the last 10, 15 years, we've seen more and more recalls and incidents that were initiated because of PulseNet. And this is the international network of laboratories that is hooked up with the Centers of Disease Control in the United States and other health authorities. And the way it works is when a clinic identifies a human being that is ill with a pathogen, then the pathogen is analyzed for its DNA, and different people are compared by the PulseNet. And if there is a national or international outbreak, it is identified. And then the governments, the authorities can act on that and try to find the source by speaking to these people. This is a really important game changer, because in the past, you could manufacture products with a little bit of pathogens, and people were getting sick here and there, but nobody could know where it was coming from, because these people don't know each other. They never met. They're just eating the same food that's been distributed from one center. Now that there's PulseNet, anybody who is manufacturing food that's contaminated has a very big chance of being caught. I'm not trying to say that if we couldn't have been caught, then we should have been putting pathogens in. But we know now that our responsibility is much, much larger because this identification is possible. And it's gone to the point where if in routine testing of food, a pathogen is picked up and we look for its DNA profile, we can now go back and find people who have been affected by that pathogen. And there have been cases where people have been identified as being affected by food years before the outbreak was identified, just from having the same DNA profile. The third reason is both of these bacteria are highly pathogenic for people who are susceptible victims. Most of the population will not get severely ill from Listeria or Salmonella, but pregnant women, elderly people, people with background diseases, and so forth can be seriously, if not fatally, harmed from these pathogens. And specifically, Listeria can cause stillbirth and abortions for pregnant women. And another special thing about these two bacteria, there's a zero tolerance for them in food, in ready-to-eat food, meaning that in 25 grams and up, we expect to see no bacteria at all. Each one of these has a special reason for that. For Salmonella, the reason is that a very small infective dose is enough. For Listeria, there's a different reason. Listeria, you can't get sick from a very small infective dose, but Listeria knows how to grow in cold temperatures. So if there's a product leaving your plant or your kitchen has just a few Listeria bacteria, the product is not dangerous. But if it's a chilled product, within a few days, it becomes very, very dangerous. So Salmonella, especially in oily foods like chocolate, peanut butter, tahini paste, and so forth, can cause disease in very small doses, and Listeria can grow in the refrigerator. Therefore, we do not tolerate any of these bacteria in food at all. Now, you may be saying we have HACCP, and shouldn't that be enough? Well, the answer is yes, but many, many organizations have had Listeria and Salmonella outbreaks, even though they have HACCP. And we have to understand the limitations of the HACCP system. I've spoken about this in previous seminars, and it's worth going back and listening. I'll just remind the participants that I classify hazards into two types. This is my own classification. This is not something from the literature. I call type 1 hazards those originating from raw materials, and these must be eliminated or reduced to an acceptable level somewhere along the process. This includes all kinds of hazards, not only pathogenic, but in this presentation we're talking about environmental pathogens. And the type 2 hazards, on the other hand, are those that can be introduced from the processing environment. Our food safety management system must be comprehensive enough to protect the public both from those pathogens that are found naturally in raw materials, type 1, and those hazards that can be introduced during processing, type 2. And that's why HACCP is not enough. We need a more comprehensive approach if we want to ensure the public is getting food that is suitable for being eaten without danger of getting sick. So CREEP, acronym for Comprehensive Risk Evaluation of Environmental Pathogens. And let's talk about type 1 first. It should be assumed that all raw ingredients, plant or animal, are contaminated with environmental fecal pathogens. This is an assumption that should be made for every person doing HACCP in any plant or kitchen. And this is really, really important to understand. Now, it's important to understand that we cannot rule out pathogens by testing for them, at least not Salmonella or Listeria. If I take a raw material from the field and I test it, and I find it to be free of Salmonella and Listeria, that does not mean it is actually free of Salmonella and Listeria. And my assumption should be that it is contaminated, even though there's no direct evidence of that. It is worth mentioning that there are rare occasions where commercial food is consumed raw. In steak tartare, sushi, cheeses made from raw milk. In these cases, environmental pathogens must be prevented in the farm and throughout the product's primary handling. This is not in the scope of this presentation. In those cases, microbial testing of ingredients should include evaluation of the presence of indicative fecal bacteria, because if I'm going to be eating, consuming, or selling raw food, and it shows up negative for Listeria and or Salmonella on microbial testing, that does not ease my mind unless I also know that there is a low level of indicated fecal bacteria. It could be Enterobacteriaceae or fecal coliforms. again, for the reasons I mentioned before. So if we're talking about raw food, it must be managed on the farm. Otherwise, and that's for everybody else, and that's the vast majority of processed food, a validated pathogen kill step should always be a critical control point. If it could be a thermal step, it could be a disinfection, it could be radiation, it could be whatever you choose, but it must be a validated pathogen kill step. And when I say validated, we cannot assume anything. Please remember that Salmonella, for instance, has a high survival rate in dry foods. And some of the thermal processing that we believe to be adequate for pathogens may not be adequate for Salmonella. This must be validated, including people who are using extruders or dryers and other types of thermal processing that have a technological purpose. Just a reminder, CCP, according to ISO 22000, is a step in which control can be applied and is essential to prevent or eliminate a food safety hazard or reduce it to an acceptable level. So remember, it can and must be applied. That is a step in the process. That is our critical control point. And when we're talking about a food that has raw ingredients, there must be a kill step. If we talk about type 2 hazards, those are the ones that are in the environment that can be introduced in the processing environment or the cooking environment. After the CCP, recontamination should be prevented by implementing PRPs and OPRPs. Now, I want you to pay attention for a second. If you have a kill step that is an additional kill step that is post-lethal, in other words, you have your first kill step, let's say you're pasteurizing milk, for instance, or cooking hot dogs, and then you go through a whole process, and at the end of the process, you're going to implement another thermal kill step. Something in your process should be re-examined because what you're doing in that case is killing recontamination. Recontamination should be prevented and not killed. So think about that and see if you have that kind of situation. So after the CCP, we must prevent recontamination, and this is by using our PRPs and OPRPs. Just a reminder of what those are. PRPs are, according to ISO 22000, basic conditions and activities that are necessary to maintain a hygienic environment throughout the food chain. So hand washing, temperature control, employee health, prevention of cross-contamination, pest control, and on and on and on. These are all prerequisite programs, what used to be called GMPs, or GAPs, or other GPs, other good practices. So we now call them PRPs. Just to remind you that an operational PRP, an OPRP, is a PRP that has been identified by the hazard analysis as essential in order to control the likelihood of introducing food safety hazards. So an OPRP is actually it is the CCP of our environmental controls. So we have many PRPs, and some of them will be identified as OPRPs. And just if anybody is confused about that, then I do urge you to go back and watch the previous webinar that I gave on the difference between OPRPs and CCPs, because it's important to eliminate that confusion. So if we're talking about implementing creep for type 2 hazards, then the following PRPs should be identified as operational PRPs. So these are it's not a limited list, but it's a mandatory list as far as I'm concerned. So ready-to-eat products that with a kill step, the zoning must be an OPRP. Zoning is crucial. Zoning meaning that you identify geographically in the plant, in the kitchen, in the warehouses, the difference between raw and prepared, between not ready to eat and ready to eat, and make a clear boundary between those zones, and manage the zones and manage the transfer from zone to zone. Changing of clothing, disinfection of hands, disinfecting materials, just looking at how we move from zone to zone, depending on its level. We call the zones where ready-to-eat products are already being handled high care zones or high risk zones, and they should be managed accordingly. This should be an operational prerequisite program. Ready-to-eat products with hand contact. In those cases, employee hand hygiene must be an OPRP, and depending on the situation, it could be hand washing and sanitizing. It could be the use of gloves. It should be a combination. We do recommend planning ahead in planning our process so that hand contact with ready-to-eat products is not needed, using tools, using other ways of not having to handle food with ready-to-eat food. But there are cases where it is inevitable, and in those cases, employee hand hygiene must be an OPRP. Situation number 3, areas where ready-to-eat products are exposed. In those areas, pest control must be an OPRP. So it's important to eliminate pests from food facilities. But where there are ready-to-eat products exposed, it's not a good idea or nice to have. It is essential. And you can focus on birds and rodents. Insects are less of a hazard for transferring Salmonella and Listeria, but birds and rodents are important. It's also worth mentioning cats, who can also carry pathogenic bacteria. Now, we do know Salmonella is present in the gut of reptiles as well, but it seems to be less of a problem in plants as birds and rodents who are attracted to the products. Equipment in contact with ready-to-eat products. In those, all equipment, this cleaning and sanitizing, or what we call the standard sanitation operating procedures, must be, or the sanitary standing operating procedures, SSOP, must be an OPRP as well. Now, what the difference between a PRP and OPRP, again, it's not the scope of this lecture, but it's important to understand that OPRPs are as important as CCPs. They must be validated, they must be monitored, they must be verified. And any product that has been manufactured or handled without the benefit of an effective OPRP in place should not be marketed. So if you have any evidence that somebody who did not wash their hands is touching ready-to-eat products, that product should be discarded even if you have no evidence of contamination. If you have any evidence that birds or rodents were active in an area where exposed ready-to-eat products are present, those products should be discarded regardless of their of what you find if you test them, because our assumption is that they may have been contaminated. So those are our OPRPs. In addition, and this is a novel approach, we recommend a spatial creep assessment, meaning geographical, looking at space, and it should be performed to assess environmental pathogen entry points. So what we're doing is looking at our plant or our kitchen or our warehouses from a geographical point of view. We're looking at the space and looking at where introduction can happen and managing those pathways. We have identified 5 major issues that allow pathogens to enter production areas and warehouses, and I'll go through them with you. The first one is packaging material. Packaging material is introduced at the end of the process, often after the kill step. Packaging material is supposed to be clean. It's coming from, however, from warehouses, and it can pass through the outdoors. So packaging material may be contaminated with pathogens that are coming from birds or from other droppings or from just environmental contamination, and therefore they must be unloaded very carefully, unwrapped in a very hygienic manner, and introduced into the plant, making sure that they are not introducing pathogens into the plant. So that's our first way of introducing through openings. Number 2, we have to think about the roof. This is really important in countries that have a dry season, but it's also important in other countries. The dry season is really important because during the dry season we have no rainfall, and during that time bird droppings accumulate on the roofs. And when the first rains start, usually in the beginning of fall, of autumn, then we'll have warm rain washing the roof and going towards our drains on the roof. And if they have been clogged because of falling leaves or pine needles, then we'll have accumulation of warm water with bird droppings being dissolved in it, and we have a lot of Salmonella and Listeria on the roof. And if the water finds a way to drip into the plant through the roof, we'll have severe contamination. But it doesn't have to. Any situation of rain and the combination of rain and bird droppings on roofs can cause introduction of Salmonella and Listeria from the roof. So they have to be very, very well maintained, cleaned all the time to make sure that we cannot have any dripping or leaking into the plant. Number 3 would be external openings. All of our doors, windows, and openings for ventilation and so forth must be kept closed and be sealed at all times, except for those specific occasions where they must be opened for exit and entrance of people and materials and equipment. But all the openings must be kept very well closed, including very, very small openings. So the whole issue of external openings should be looked at very, very carefully. Many of the pest control companies will offer this service of doing an external opening survey to see if the plant is actually sealed as we would like it to be. Number 4, shoes. Most food plants, if they are not a very high-risk plant, employees will walk into the plant with their shoes from outside, meaning that they are potential of bringing feces, fecal material, on their soles of their shoes into the plant when it now could be present on the floor. So anywhere where we have a high care area, we want to make sure that shoes are either outdoor shoes are changed, protected with foot coverings, changed onto boots, or disinfected. But do make sure that shoes are not allowing environmental pathogens to enter the plant. And finally, sewage. Our sewage system must be made in such a way that if there's ever a backup or stoppage, it cannot find its way back into our sanitary equipment. And we need a PRP, very, very good PRP to manage sewage, because sewage does contain human waste, and it is full of environmental pathogens. Of course, there are more, but we find that over the years we've seen most contamination environmental contamination that's entering the plant, surprising us, coming from these 5 sources. Okay, so there's a little button here that says press. So I guess I'll press it. See what happens. You ready? Boom. Okay, just to show that in order to remember our creep, I've given it an acronym, PRESS, P-R-E-S-S, packaging, roofs, external openings, shoes, and sewage. Should make it easy for you to remember when you're doing your HACCP and your environmental studies, where the environmental pathogens can be coming in from. And we're nearing the end of the presentation, so just another reminder, verification. This is really, really important. Confirmation through the provision of objective evidence that specified requirements have been fulfilled. So what ISO 22000 is saying is, in other words, never assume that something is happening. It must be verified. And PRPs must be verified by careful observation, by using cameras. And we've spoken about some of those in a previous seminar, talking about novel ways of verifying OPRPs. Now, it may include pathogen testing of finished goods and process environment. And many organizations will do that. They will test products and environment, take swabs, looking for pathogens. However, it is more effective to test for bacteria that indicate fecal contamination than looking for the pathogens themselves. If you have a fecal contamination and you find enterobacteria, say, or fecal coliforms, but you don't find Listeria and Salmonella, they're probably there. It's finding Listeria or finding Salmonella in environmental testing and product testing is like looking for a needle in a haystack. But it's important to remember these pathogens, they live in a community. They don't appear in a purified form. They're always with their friends. They all come from feces, and feces has a whole bunch of different bacteria that appear. Luckily, most of them are not pathogenic, but they tell a story. And if they're present in numbers that are exceeding what is acceptable, and even if we don't find their pathogenic friends, we should assume that they're there, and therefore the product should be deemed unsafe for use, or the environment should be resanitized, and products that were manufactured in the contaminated environment should be considered for destruction. So let's wrap it up with some take-home points. The war against environmental pathogens requires a multifaceted, comprehensive approach. We cannot just use HACCP. We can't just say, yeah, I cook, so I'm okay. We can't just say we test for pathogens and we don't find them, so we're happy. Remember, in the last 20 years, every single organization that had a severe outbreak of Salmonella or Listeria, including death, closing of plants, massive sickness, all had HACCP. All their CCPs were in place. They just allowed the Salmonella or Listeria to enter it from a different way. Nobody should ever become ill or injured from their food. And that is something that I say in every seminar. If anybody there is thinking, well, this guy's crazy, it's impossible to eliminate all hazards from food, then you're wrong. Nobody should ever become ill or injured from their food. It is our responsibility to find where our pathogens are coming from and eliminate them from the food chain. And finally, one of the most annoying sayings that I've ever heard is that what you don't know can't harm you. And I want to make sure everybody understands that what you don't know can harm you, and the knowledge is what we need to protect the public, and it's our responsibility. So, thank you for your kind attention. And again, I apologize for not being here live to take questions, but I'm sure Simon will do a great job of getting all your questions to me and all of your remarks and feedback. And I promise next time you'll be able to meet me face-to-face using the webcam. So thank you very much, and bye-bye.